and PBS. So all the little balls are the different nitrogen bases. The blue is adenine, which connects to the yellow thymines, which you can see here. And then the green ones are the cytosine, which connect to the orange guanines. The guanines and the adenines both have like the double ring structure, if you can kind of see the little double balls on them. And each of the nitrogen bases connects to the sugars, which are the little googly eyes, which make lovely noises. And each googly eye connects out to a phosphate. And they keep going up. All the way up.
Double and triple bonds?
So between the adenine and the thymines, there are double bonds. If you can see the two little black lines, and then between the cytosines and the I can't remember the guanines, there's 3 triple bonds, which are 3 little black lines. And
Hi, my name is Tiffany Benoit, and this is PBS, and this is my DNA strand. And if I can get to twist a double helix, and I'm going to untwist it to show you everything. Red is cytosine, yellow is guanine, green is thymine, and blue is adenine. And the dual balls are the sugars, which connect to the phosphate group. And then cytosine has...
Can you pick it up? Will it break, or are we good?
I don't think so.
Because it's closer to you. Awesome. Okay, talk to me.
Cytosine is the red one, and it has a single ring, while guanine has a double ring, and it has 3 bonds. And then the green is thymine because it has a single ring, and the blue is adenine because it has a double ring and it has a double bond.
Excellent. Okay. Anything else? More you want to
Hi,
add?
I'm Sam Haynes, and I'm Principal of Biomedical Science. This is my DNA structure. Okay, so like nucleotides are made of like a deoxyribonucleic sugar, a phosphate group, and nitrogenous bases. It forms a double helix, and then you have your nitrogenous bases, which is like adenine, guanine. Those are purines, which has a double ring structure, and you have your thymine and your cytosine, which is a pyrimidine, which has like 1 ring, and then they have like different bonds coming off of it. And then A goes with T through a double bond, and then C goes with G through a triple bond. Like,
Is that shown somewhere in your model, the different kinds of bonds, or not really?
not extremely.
Okay.
I kind of just like bonded them.
Rings, and same thing, and the ring structures are not.
Yeah,
Like they're color coded, but not okay.
Yeah, I just had no idea. Like, I totally would have made a separate thing. And then they form a double helix, basically.
Which colors represent what on the sides, like the sugars and phosphate?
So I have.
I asked because you have one side in one color and one side.
Oh, I
in
ran out
another.
of colors.
Okay. All right.
So I have like the sugars are like closer towards it. Like I have like green and purple as like the sugars, and then I have the blue and orange as the phosphate groups. And I kind of had them alternate, so like it kind of.
Okay, so but you understand that in an actual DNA there is only one sugar and one phosphate in between, not.
Yeah, I just put all these through
have.
here, and I'm like, I can't take this off now.
Okay. All right. Anything else you want to add?
Okay, my name is Ruchi Patel, and this is Biomedical Sciences. And for Biomed, we had to make a DNA molecule, and this is mine. As you can see, it has a double helix structure, and it's made out of 3 components, which is our phosphate group and our sugar group.
Show me where that is on the model.
Okay, so my phosphate and sugar are represented by the green and red bead. And
Which
then
one is which?
My sugar is my red, and my green is my phosphate. And then the nucleotides are in the middle right here. And I'll go further into that in this molecule.
Okay.
Okay, so this is it bonded. I didn't know really how to do it single. But here is our pyrimidines and purines. And this is our adenine and thymine bonded together.
How do we know that?
Because it has the 2 hydrogen bonds, so you know that it's adenine and thymine.
And which one is which?
since this is our purine, this is our thymine, and since this is purine, this is our adenine, and the pyrimidine is our thymine.
Excellent.
And my individual, you might not be able to see the beads, but here's my sugar again, and here's my phosphate. My dark blue beads are my nitrogen. My yellow beads are my carbon. My hydrogens are in the white, and my oxygens are in the purple. My regular covalent bonds are shown by the yellow pipe cleaners. My red pipe cleaners show my double bond, and my purple show hydrogen bonds. So that's that together.
Excellent. And then we have one more set.
And here's the same thing again, but the only difference in this is I used green pipe cleaners for the regular bonds, and the rest are the same. So like my double bonds are right here, and my hydrogen bonds are here. The atom colors stayed the same with my sugar and my phosphate, my carbon, my nitrogen, my hydrogen, and my oxygen. And this would show guanine and cytosine.
Which one is which?
So cytosine is again the single ring right here, which is our pyrimidine, and guanine's our double ring, which is our purine.
Excellent.
Biomedical science. See, it's twisting. This is my DNA model. So the clear spice drops are the sugars. The twizzlers will be the phosphate, and the red is the adenine, and the orange is the thymine. And I put 2 marshmallows in between it because of the double hydrogen bond. And then the green is the guanine, and then the yellow is the cytosine. And I put 3 in between because it's 3 hydrogen bond. I didn't like, for the adenine and guanine, I didn't like have anything to represent like them being purines, but like they have double like 2 rings and stuff. And cytosine and thymine, they have just 1, so that the pyrimidines, pretty much. Only the sugar connects to the nucleotide, and the phosphate connects to the sugar. Anything else?
Does it twist?
It twists.
Awesome.
Like this.